Welcome to the second of the primary sessions for Protect Our Planet Day. Over the next hour, we will delve into the Earth's ice and oceans. We'll examine the challenges these ecosystems face from climate change and discover the actions needed and those already taken place to protect them. You'll learn from and be inspired by scientists working in the fields. I'm Sarah Dagnall and I work here at the STEM Learning Centre in York. I will be guiding you through the hour, introducing you to amazing people and showing you a really cool activity which I hope you can join in with at school or at home. You'll also meet Naomi and Lucy, who have teamed up with the amazing BBC show Frozen Planet 2. They will explain why the Earth's frozen regions are so important and perform an experiment from a research ship, the RRS Discovery in Dundee. They'll teach us the difference between land ice and sea ice, and we'll see how important it is to protect our ice. Not just for the animals who depend on it, like the harp seal, but also because what happens in these regions impacts all of us. We'll then go to the bridge of the RRS Discovery and the RRS James Cook to meet the people at the helm. You'll uncover more about what they do and how the ships are involved in protecting our planet. You'll then meet a research scientist who works for the National Oceanography Centre, NOC. NOC carry out research on the world's oceans, particularly focusing on the effects of climate change. We'll see a deep sea submersible known as Boaty McBoatface and learn how it dives to the depths of the ocean to carry out important surveys. These help scientists understand and battle the effects of climate change. We'll plunge into the dark depths of the ocean to discover some of the monsters that live there. Some of the creatures are as big as skyscrapers. Some glow with bioluminescence and others await their prey with mouths full of extremely long needle-like teeth. Seemingly hidden from the life above the waves, these creatures also face the effects of climate change. Are you ready to come face to face with some of the aliens of the ocean? There'll be a chance to ask Matt Kingsland, a scientist from NOC, questions and discover more about his job and how we can protect our oceans. So make sure you enter any questions you have into the online chat, ready for me to ask during the live question and answer session. But first, let's go over to Dundee to meet Naomi and Lucy on the RRS Discovery.
Hi everyone, I'm Lizzie.
And I'm Naomi, and we've teamed up with BBC One's Frozen Planet 2 for a live lesson investigating one of the coldest places on Earth, the Arctic. We're in Dundee in Scotland on the RRS Discovery, Britain's first polar research ship.
We've been learning about harp seal pups, how their icy home is being affected by climate change and the scientists working to protect their future.
Ask a grown-up to find the whole lesson on the BBC Teach website. But today, we want to show you a really fun experiment we did to learn the difference between sea and land ice and why it's so important to protect it. We know you're all learning about this in today's Protecting Our Planet Day. So I reckon we might need to wrap it warm for this one, Lizzie.
I think so.
Before we kick off, let's take a look at Frozen Planet 2. Now, we are in the wardroom on the ship where the Discovery's crew planned and plotted their own adventures. The first voyage in 1901 included a stopover in New Zealand.
As the Frozen Planet 2 team found, polar regions are some of the most challenging environments to explore. Captain Scott and his crew also came to realise this when the Discovery got trapped in the Antarctic ice and had to be rescued by 2 other boats.
Despite those challenges, it's never been more important to explore and study the world's polar regions, which are being impacted by climate change.
What is climate change? Climate change refers to the shift in the Earth's usual weather conditions over many years. Our world has been getting hotter due to things humans are doing, like burning huge amounts of fossil fuels, cutting down too many trees, and over-farming crops and animals.
So what's the difference between climate change and global warming?
It's a good question. Global warming is the process of our planet heating up, and rising temperatures mean that the ice in the polar regions, like the Arctic, is melting fast.
But Arctic animals, like harp seals, depend on sea ice to hunt for food and to survive, don't they?
They do, and melting sea ice is also forcing pups into the icy waters before they are fit and ready.
Unfortunately, when filming Frozen Planet 2, the team saw this firsthand.
He may not be keen to take the plunge. The salt water is -2 degrees Celsius after all. Pups start with a doggy paddle. Mum stays reassuringly close. Still developing his insulating blubber, a pup is at risk of hypothermia, so needs to rest and warm up. Each day he puts on another 2 kilos. And practices swimming for just a little longer. Since birth, this pup has tripled in weight, and he's now at ease in this curious other world. "12 days gone by. A mother's work is done. Surviving on his fat reserves, as his downy fleece is replaced by a sleek coat more suited to swimming. But temperatures in the Arctic are now rising faster than ever before, creating storms that break up the ice floes earlier each spring. Harp seal pups are being tipped into freezing waters before they're ready to endure long periods at sea. In some pupping areas, almost none survive.
Rising temperatures can cause ice in polar regions to melt, and there are 2 different types of ice in the polar regions.
Sea ice, like we've seen harp seals depend on, is frozen salt water from the ocean. Land ice, like glaciers and ice sheets, is fresh water and can be found in places like Greenland in the Arctic.
Is the difference between the 2 important, Lizzie?
Yes, we're going to find out which type of ice contributes more to rising sea levels. Is it sea ice or land ice? Let's find out.
So we've got 2 identical containers. In each one there is clay, that represents the land, and an equal amount of water to represent the sea. We've also just placed an equal amount of ice cubes in each container.
In this box we have placed 4 ice cubes in the water. This represents our sea ice.
And in this box, 4 ice cubes on the clay, that's our land ice.
Now let's measure our starting water levels. So
Okay.
Naomi, let's have a look in our land ice. So Naomi, what's the depth on that one?
So I would say that's probably about 30 millimetres. I'll just mark that waterline as neatly as I can.
Oh, fantastic.
And record the results. 30.
Of course. Okay, let's have a look at our sea ice. So, in we go. What's that measuring, Naomi?
That's reading at 35 millimetres. Great, let's mark that as well.
Okay.
35.
Now, we need to wait for the ice to melt. We set up the same experiment earlier so we could show you the results. Before we reveal them, it's prediction time. Adventurers watching, we want you to work out which box you think will have the highest increase in water level when the ice melts.
So will it be box A, land ice, or box B, sea ice? For activity 2, you have got 45 seconds to make your prediction and discuss it with your classmates. Ready, steady, go.
Have you decided on your answer yet? Before Naomi and Lucy reveal the correct answer, we've got another amazing Frozen Planet 2 clip to show you.
A Pallas's cat. He has the densest fur of any cat in the world. Nonetheless, to keep warm, he must catch up to 5 rodents a day. Top of the menu are voles and gerbils. Relative to body size, Pallas's cats have one of the shortest legs of any cat. And that helps by giving them a low profile when stalking. But it's not so good for wading through deep snow. Never mind, there are plenty more. He just needs to stay focused. Unfortunately, the longer he's out in the snow, the colder his paws become. And he has only one way to get the blood circulating again. That could be one shake too many. Only one hunt in 3 by a Pallas's cat is successful. No wonder he has the reputation of being the grumpiest cat in the world.
How did you get on? Let's find out if you're right.
Okay, let's have a look, Naomi. So, here we go. Let's start with sea ice, shall we?
The new water level in sea ice, oh, it's barely changed at all. It's at 36.
Oh, okay.
Okay, so I'll add that to
1
my
millimetre.
chart. 36.
Okay, and land ice.
Land ice. Oh, now that one is different. That one has gone up to 35. So that's a big increase from what it was before. It was 30, now 35. I'll record that.
So the correct answer was box A, land ice. And that's because the sea ice was already in the water. So sea levels don't rise much when that type of ice melts.
But land ice melting can impact sea levels as it adds more water, which we can clearly see from our experiment.
Land ice melting is one of the largest contributors to the global sea level rise. Scientists say that if our planet's temperature goes up too much, it could cause low-lying coastal areas and islands to end up underwater.
Melting sea ice is also causing problems for creatures like the harp seal that need ice to hunt and survive. What's happening in our polar regions could have a global impact.
Frozen Planet 2 is available to watch on BBC iPlayer. And you can watch the full Frozen Planet 2 Science Live lesson on the BBC Teach website. Visit bbc.co.uk/teach, or on iPlayer search for BBC Teach Live Lessons. Now, I wonder how many of you predicted that land ice would have the biggest effect on sea level rise. It's a great activity to try out at school or at home, and it goes to show why protecting our Earth's ice is so important. Sea level rise is destructive, and it could cause damage to coastal areas, cause flooding and loss of habitat for fish, birds and plants. It's incredible that despite the cold, harsh conditions of the Earth's frozen regions, so much life exists. But all life faces the threat of the effects of climate change. Thankfully, the scientists working on the RRS Discovery and thousands of others across the world are working hard to discover ways we can protect our ice. The host of our Protect Our Planet Day secondary sessions, Susie Ember, had the privilege of speaking to the captains of the research ships RRS Discovery and RRS James Cook earlier this week. Let's watch the interviews and find out more about life on a research ship.
Hi, Stuart from the RSS Discovery. Are you there?
Hello.
What is your scientific goal? What are you going to be doing on this expedition?
So we're working on a project with CFAS, and it's the Blue Belt project. So we are essentially looking at ways of managing the marine protected areas which are around the overseas territories. In this particular case, around Ascension Island and St Helena. So that's ultimately where the ship will be getting, going down towards, working around these islands to try and learn more about the oceans and the sort of ecosystems that are around these islands in order that we can protect them in a more efficient and manageable way.
So I know we do a lot of work on looking at the oceans and managing the oceans using remote sensing observations, so using satellites and other instrumentation to look down at the oceans. What advantage do you have as a vessel actually in the oceans? What measurements can you make that we can't make any other way?
We've got a very capable sort of hydroacoustic suite capabilities there, so we can map the seabed really in fine detail. We can find fish. We can use our sub-bottom profilers, which would give us a map, an image of what's beneath the surface, what's beneath the ocean floor, so we can have a look there. Really the ship itself, it's very adaptable and flexible, that we can provide seismic research, we can work with ROVs, we could work with autonomous vehicles, we can take seawater samples. So we're really flexible, really capable for a variety of different oceanographic requirements.
Thank you so much, Stuart, for joining me today. It's been a real pleasure talking to you.
You're very welcome. We're happy to help.
James, great to see you today. Tell me a little bit about your ship. Where is it today, and what are you up to?
So we're currently about 400 miles off the east coast of Canada, off Newfoundland, and we're working with the Canadian government, helping them with an annual survey that they do, and they've been doing it since 1998. They take readings and samples of water from all around the coast of Newfoundland and Nova Scotia, just to see how things are changing. So they're looking at water samples, biology, plankton, chemistry of the ocean, stuff like that. So it's an ongoing project for them. So it's important that they don't miss any samples of it in the spring and in the autumn, which is the one that we're doing now.
Fantastic. And I gather that some of your work addresses climate change. I know this is definitely a topic of interest for many of us. So can you tell us a bit about how your work goes about addressing climate change?
Yeah, so a lot of the work the scientists do is geared towards that. We do take different groups of scientists out all the time, so every trip is different, a different group of scientists, but a lot of the work that they're doing is geared towards climate change. They're measuring how things are changing, acidification of the oceans, how much it's warming up. Sometimes they'll be taking air samples as well as the water samples, and they can see how mainly how the sea is changing, how the biology in the sea is changing, how the chemistry in the sea is changing. So it's quite a big subject, obviously.
What are the kind of highlights of your job? What are your career highlights so far?
So it's mostly, particularly with this job, it's always interesting working with the scientists. So we've been to some interesting places. Particular highlights would be working down in the Southern Ocean around Antarctica. So last year we went to have a look at a big iceberg that had broken off from Antarctica and was threatening to ground off South Georgia. So that was quite interesting. So we had to try and get quite close up to this giant iceberg, which had lots of smaller bergs and bergy bits and growlers and things like that around it. So that was quite interesting.
That sounds fantastic. And I guess the other highlight must be that you get to see some really interesting wildlife being out at sea for so many months in so many different places. Can you talk a bit about the animals that keep you company on your expeditions?
Yeah, so majority of the creatures you see, obviously, are whales and dolphins, I suppose. They can be quite elusive, but on occasions they do come up very close to the ship. So again, a few years ago we were in the Southern Ocean. We were stopped in the water doing an ROV job, so the ship wasn't moving, and we had about 4 or 5 humpback whales who came up extremely close to the ship to have a look at us, and they were there all day. They were swimming around the ship, and you could almost reach out and touch them. They were so close.
Captain James, thank you so much for joining me today. It's been a real pleasure speaking to you, and good luck with the rest of your expedition.
Many thanks to Captain Stuart McKay from the RRS Discovery and Captain James Gwinnell from the RRS James Cook for giving us the time to talk about life on board and the incredible work that happens on the ships. We know that the scientists trying to protect our planet need to collect data in different ways. But some areas of the Earth's oceans are tricky to collect accurate data from. In one particular area, where the harsh Antarctic conditions had made collecting data on the sea level rise difficult, the researchers came up with a unique solution. Researchers from the University of East Anglia and the University of Stockholm linked up with the Sea Mammal Research Unit at the University of St Andrews. They attached sensors to the heads of 7 southern elephant seals and 7 wheedled seals. The seals collected more than 5 times the amount of data that had been previously produced. Unlike the research ships, the seals are in the area all year round and can stay in horrible weather that the ships can't be in. They are the perfect Arctic researchers. However, one of the more usual ways to collect data in the oceans is through using autonomous underwater vehicles. They are robots that travel underwater. NOC use these in their research of the oceans. Their most famous ones are called Boating at Boatface, and they are carried on board the polar research ship, the RRS Sir David Attenborough. These deep sea divers are used to collect data on the effects of climate change in our oceans. Matt Kingsland from NOC will tell us more.
Hello, my name is Matthew Kingsland. I am an engineer here at the National Oceanography Centre in Southampton, and I am here today to talk to you about Boating at Boatface, which is this vehicle that you can see in front of you here. Boating at Boatface was designed to do long-range, long-term autonomous science, and by that I mean she goes a very long way and does science en route. So by long way, I mean over 2,000 kilometres she can do, which is the equivalent of travelling from here in Southampton to southern Spain. She would take just over a month to complete that route because she goes incredibly slowly at about 0.5 metre per second. That is slower than walking pace. And she goes that slowly because we get very, very good energy consumption out of the vehicle when going that slowly. So here is one of our vehicles without the top hydrodynamic cover on the top of it. And we have 6 of these vehicles, and you can see 2 in front of you here, which look ever so slightly different. In the front of the vehicle, we have all the sensors, which you might describe as the eyes and the ears of the submarine. Going back from that, we have the batteries, which live in this pressure vessel here. And then we have what we call syntactic foam, and this is the buoyancy of the vehicle and makes sure it doesn't sink. Coming further back, we have a pressure vessel with the electronics inside of it. And then at the very back, we have the navigation system, the propulsion, and the maneuverability, which are in the fins and the actuators at the back. We also have this antenna here, which is for the communications. So we control this vehicle via either Wi-Fi, very similar to what you have at home, or satellite communications, where we send the vehicle the equivalent of a text message or a WhatsApp message. Okay, so how do we navigate under ice and how do we avoid ice in the deep oceans? So on the front of this vehicle here, we have this acoustic device, and when I say acoustic, it transmits sound waves which get reflected off of obstacles in front of us. So we call this the obstacle avoidance system. It works very similarly to how a bat uses echolocation so it doesn't hit anything when it flies. So how this works is from each of these 4 white acoustic transmitters, we produce some sound which gets reflected off any obstacles in our way. So this could be ice, it could be seabeds, it could be a very large cliff. If we knew what was there, we wouldn't need to go there to explore. So we have to program these autonomous vehicles to be as smart as possible to be able to make decisions without us, because when it's under the ice, we have no communication with it. When we launch it from a ship and it goes under the ice, it will come back a few days later after making decisions for itself on where it should go and what it should do. These are critically important things because of these obstacles. There may be something there which is in the direct path of the vehicle and it may have to work around it, avoid it, or it may decide to turn back if it's too dangerous to continue. We weigh up the decisions on whether it's too dangerous to continue on value of the science. So this vehicle does under ice science which feeds into climate change models, weather prediction models, and once it's collected that data is incredibly valuable. More valuable than the vehicle itself, because educating ourselves on how climate change is affecting the world around us, how the sea ice is melting, how the ocean is mixing between the fresh water and the salt water around the polar ice caps, is incredibly important to us at the moment with the climate change. So recently one of these vehicles, just this past winter, went to the Antarctic to a place called Thwaites Glacier. And you might see Thwaites Glacier in the news a lot at the moment. It's been called various things, but the important thing to know about Thwaites is it's a very good example on how sea ice is melting and what we can learn about other places in the ocean which may also be melting. We recently sent one of our vehicles there, and which went under a ice shelf very nearby, which collected data for 3 days under the ice cap, which is being used to predict how sea levels will rise, and in turn, how will that affect you? Will the beach disappear? Will the ocean rise and start flooding roads? How is the ocean going to affect our daily lives? And this is very important science because it affects us, and how much CO2 we put into the atmosphere from our carbon emissions affects how much these glaciers are melting. And this is all a cycle of cause and effect. We put more CO2 into the atmosphere, we cause more global warming, the ice warms up, the ice melts, and that affects us by raising the sea levels. So as we use less carbon fuels and we pump less oil and gas out of the seabed, the infrastructure that was there either needs to be taken back on shore and decommissioned, or in the case of old wells, which are holes drilled in the ocean, they need to be monitored to make sure they're not leaking. And this vehicle, Boating Boatface number 3, was recently up taking photos of old decommissioned oil and gas wells in the North Sea. In the middle of the vehicle, underneath, it's got 2 cameras. This is so we get very high quality data, and at the front and the back we've got some very, very bright flashlights. This is because the sea is dark once you go past 50, 100 meters, and sunlight doesn't penetrate down that far. So we take these very bright flashes and we take pictures of the seabed to monitor these old man-made structures which are now decommissioned but we can't remove from the seabed. And the vehicle launched from Shetland. It drove from a beach in Shetland out to these old oil and gas drilling sites and pumping sites. It did a survey around them, took a huge amount of photos, and then it drove itself back. We did not need to use a large diesel ship to collect this data. All we needed to do was crane this vehicle off of a quay wall or a sea wall, tow it out with a rib until it was in open water, and then it can take care of itself. And it drives itself all the way to these oil and gas sites, and it does the survey and it drives itself all the way back. This is a very low carbon way to collect oceanographic data. So we've moved to this other workshop here at the National Oceanography Centre to explain how we use pressure with our vehicles. So our vehicles are always positively buoyant. This means they float. And this means if something was to go wrong with our vehicle, they would come to the surface and we'd be able to find them again. However, there are times when we don't want our vehicles to float, and this can work to our advantage. If we make our vehicles negatively buoyant, which means they weigh more than the water that they displace, we can make them sink. Now, this is a very efficient way to move through the ocean. And we do this by using what we call an oil bladder, and we pump oil in and out of the pressure vessel that we have on our submarines. So when we would like this particular submarine to sink, we suck in the oil from the oil bladder. The submarine still weighs the same, but it's displacing less water. and thus it will sink. When we want it to come back to the surface, we pump the oil out of the pressure vessel, back into the bladder, and the submarine still weighs the same, but is now displacing more water. And this allows the submarine to gain buoyancy and come back up to the surface. The experiment that you are going to see in a moment uses a very similar principle to this real-life example.
Hello everybody and welcome to our question and answers in the Ice and Ocean primary session. We have with us Matthew Klingsland, Matt from NOC, that's going to answer our questions that you've been sending in. And we've got some great ones, Matt. We've kind of got two camps. We've got some that are about boaty and we've got some that are about climate change. So I'll start off with a couple of boaty ones. And I think the one that we're all thinking about is why is boaty yellow?
So boaty's yellow because we call it a harmless scientific instrument and we don't want it getting confused with anything else. So to find it in the ocean when we recover boaty after it's done its missions and after it's done its amazing science, the yellow helps it stand out from the blue of the ocean. So we're there with binoculars and like flashlights trying to find it, and the yellow just helps us find it again.
So not just the engineer's favourite colour.
No, we had other ideas for the favourite colour, but the yellow's the classic.
Another question we've had about boaty is how do you get him into the water?
So we use a variety of different ways. So one is all our ships have quite large cranes on them, and we effectively pick it up, we put it over the side, and then we have what's called a release hook, which is a rope which is tethered to it, which then releases it from the crane.
Fantastic. We've also been asked, the other thing that's on everybody's mind is why did he why was he named Boaty but Boatface?
So I don't know if you're aware, but there was a competition to name the UK's new Arctic icebreaker. Now, the name which was chosen in the end was the Sir David Attenborough. So the ship got called the Sir David Attenborough. But they loved the name Boaty McBoatface so much that they decided to call our submarines Boaty McBoatface because they're going to be on the ship with the Sir David Attenborough. They're going to get launched from the Sir David Attenborough. So it's a nice pairing of the two.
No, that absolutely makes sense. I love the name. Some climate change questions for you now. So we St Mary's Primary School wanted to know what will happen if we don't look after ice. They were thinking a lot about the animals. Will they survive?
So it's quite dangerous for penguins, particularly as the ice breaks up. They can get caught on the ice, which takes them further and further out to sea, away from their natural habitat. So particularly for the penguins, it's quite dangerous. And there are all sorts of other ecosystems which depend on that ice and the kind of the fresh water melting, mixing with the salt water in the sea, and those processes which combine the two. So from very, very small microorganisms all the way up to large whales, they all depend on this very delicate balance. And if we disrupt that balance with climate change, then it's not good for the animals and their how they live.
And I know that we've heard that the melting ice is causing the seas to rise, but will we actually see a point where there's no ice?
So the ice has decreased over the last 30 years by 15%. So it's already making a notable change to the amount of sea ice, which is in the Antarctic and the Arctic. And that melting ice has caused our sea levels to rise by 3 to 4 millimeters per year. Now, that might not sound like much, and if you look at it on a ruler, it's quite a small amount. But that continuous melting over many, many years, and this has been happening for the last 100 years, means our sea levels are going up. And we will, particularly if you're by the coast, notice the difference.
So Murray Primary School wondering, is there a way of us getting rid of excess water?
So there isn't a way for us to get rid of excess water. We have the amount of water that's on the earth. It's what we do with that water, which is important. We're always going to have the same amount of water on the planet. So whether it's stored as ice, whether it's as salt water in the ocean, or whether it's fresh water on land, we always have to put it somewhere. And the vast majority of it is as salt water in the sea.
Lovely, thank you. So we come to the problem of what do we do about it? And as scientists, what are the scientists around the world doing about this?
So the scientists around the world can only do so much. So we try and research and we try and inform you what you can do to make these changes. So we can't make all the changes ourselves and we can't save the planet by ourselves. We have to rely on everybody to do their part. And that comes down from the smallest things like, should I drive to the shops, or could I walk, or could I cycle somewhere? How many flights you take a year. Flights are a massive contributor to carbon emissions high up in the atmosphere, so it has more of an effect. So if you release carbon from your car at ground level, it's a lot less impact than, say, if you took a flight to a foreign country and released the same amount of carbon dioxide. So reducing your flights and taking more trains, particularly when you're within the UK, do you need to fly to somewhere else where you could get a train? And trains are one of the best ways that we can kind of help the environment with our travel, and other public transporters as well. So just thinking about how you travel is a big one. And then also how you use other energy, leaving the lights on at home. My parents always used to tell me off for leaving lights on in my bedroom when I could have turned it off. And that light being on is burning carbon fuels unnecessarily. So always turn your bedroom light off. It will save your parents money and they'll be very happy with it, and it will help save the planet.
Oh, some great lessons there, Matt. Thank you. Lily from Neatis Head Primary was actually wondering about plastic and plastic in the oceans, because she was saying, well, she was asking, how far can plastic travel, and has it actually reached the Arctic?
So plastic is a big one as well. People sometimes confuse the carbon output and the plastics. They are two very separate problems. We have carbon global warming, and then we have our pollution in the ocean, and they are two very separate topics. And the plastic that we put into our ocean is a massive problem. It gets eaten by fish, like small bits of it, and then you eat the fish. So you are potentially eating what we have put into the ocean. And yes, it has reached the Arctic. So plastic has reached the furthest depths of the ocean. It's at 10,000 meters down in the Marianas Trench. They have found our rubbish that we have put out. And it is a big problem, because getting it back from the ocean is a cold, dark place that we haven't fully explored, and finding all that rubbish again. So it's best to not put the rubbish in the ocean in the first place. So always put your litter in a bin. And if you see any litter, put it in the bin. Make sure it doesn't get swept up by the storms that we've been having recently and get swept in the ocean by the wind. So yeah, it's a big problem. And yes, it's reached the Antarctic.
That's brilliant. And thank you so much for answering those questions, Matt. I know the children back in their classrooms really appreciate that. We're going to go back in a second to our session. Please bear with us a few seconds whilst we load it back up. And thank you once again, Matt.
Thank you.
It's incredible how BOTI manages to dive to the depths of the Earth's oceans. And thanks so much to Nock for explaining how it is possible. We'll return to Nock shortly to be introduced to the creatures that survive in the depths of the ocean, the monsters of the deep. But first, I'm hoping that you'll join me in an activity that you can try out at school or at home, which demonstrates how BOTI descends, goes down, and ascends, goes up in water. We're going to make a Cartesian diver. Here's an example. I squeeze the bottle and the octopus descends. I let go and up it comes again. So, to make a Cartesian diver, you'll need a large empty plastic bottle with a screw top, water, and either a pen lid and a clip and some plasticine to make a Cartesian diver like this, or a sauce sachet to make a Cartesian diver like this. I'm going to show you how to make the Cartesian diver. Then we'll give you a few minutes to make one yourself. Here we go. First, unscrew the lid of the bottle. And then fill the bottle all the way to the very top. It's a good idea to do this over a sink or a washing up bowl so that the water doesn't go everywhere. If you're making the version with a sauce sachet, simply pop the sachet into the bottle so that it floats at the top. If you've lost a lot of water, fill the bottle back up. Then screw the lid back on tightly. To make the version with the pen lid, use a bit of plasticine to block up the hole at the top of the pen lid. Then add a ball of plasticine to the bottom of the pen lid. Now add the pen lid to the bottle. You want the pen lid to float when you put it into the bottle. If it doesn't, empty the bottle and remove the lid. Take off some plasticine and try again. Once the pen lid is floating, fill the bottle back up if you've lost any water. Then screw the lid back on tightly. Now you should be able to squeeze the bottle tightly and see the diver descend. Then let go and the diver will ascend back up to the top. Now it's your turn. Whilst you work, we'll show you a clip of an autonomous underwater vehicle in action. Enjoy! How did you get on? Does your diver descend and ascend? Either way, I expect there's a question on your mind. How does the diver work? When you put the diver into the water, the trapped air bubble inside the pen top or sachet makes the diver lighter than water, so it floats. When you squeeze the bottle, water is pushed up into the diver, squashing the air into a smaller bubble. The pen top or sachet now has more water in it, making the diver heavier, so it sinks. When you relax your grip on the bottle, the air in the pen expands again, pushing some of the water out. This makes the diver become lighter, so it rises up and eventually floats again at the top of the bottle. Boaty works in the same way our diver does. Pumps let water in and out. When filled with water, it descends. But when the water is let out and the space is filled with air, Boaty goes back up. There are creatures in the ocean that only deep sea divers, such as autonomous underwater vehicles, can reach and study. Dr. Tammy Horton from NOC will explain more.
Hello, my name is Tammy Horton and I work here at the National Oceanography Centre in Southampton. Now today we're standing in the Discovery Collections, and this is a unique resource that holds all of the samples and specimens that we've been collecting from our deep oceans since 1925. Now the deep ocean is a unique environment. It's extreme. And we imagine what it's like to be in that environment, which we're never going to actually be in, of course. It's very cold, about freezing down in the deep depths, and it's very, very high pressure, and it's also incredibly dark. So as soon as we get below about 400 meters depth, all light has disappeared, apart from that produced by bioluminescent organisms, and those are the ones that light up, and they light up to do things like scaring off predators or attracting prey. Now, these animals are well adapted to their environment, but they may seem very alien to us because of this unique environment. So we have strange animals like this. This is a twilight zone squid, and it's called Megalops, and you can see it's got incredibly large eyes. These are its big eyes, and that enables it to see those bioluminescent flashes in the dark. And a lot of the animals are inky black or bright red, and these are pretty much the only colours that you can see in the deep ocean, or that are found in the deep ocean animals, and that's because these enable them to hide in that dark depth. But there's also animals that are more normal to us, things that we expect to see in our shallow waters. So you've probably all seen a starfish before. These are starfish, and we find starfish in the deep ocean as well. In fact, they're incredibly important, and they move along the deep sea bed, feeding on the food from up above. And that's one of the other interesting things about the deep sea, is how food limited it is. So the food isn't produced in the deep sea like it is in the shallow waters by phytoplankton, but it falls like a snow from the upper oceans above. And these animals feed on that falling food called detritus. So these animals are very important. And we also have holothurians, or sea cucumbers, which are also very important grazers of that detritus in the deep sea. Now, climate change is going to have big impacts in our deep oceans. Our deep oceans cover half of our planet. We could probably call it planet ocean rather than planet Earth. And climate change will cause changes in the temperature. I've already said that it's almost close to freezing in the deep oceans. So if it increases the temperature, that's going to impact all of these animals that live in that environment. Also, it could change the oxygen levels. So, and that could also change the acidity, making it more acid, meaning that animals have to move elsewhere. And there's only very few places that they can move. So this is going to make big impacts on our deep ocean environment. One of the deep ocean animals that you may be familiar with, or at least have heard of, is the anglerfish. Now these were in Finding Nemo, for those of you who have seen that lovely cartoon, and they are real animals and they live in our twilight zone. So about 500 to 1,000 meters deep. And these have a bioluminescent lure. And you can just about see that coming down the front of this animal's head. And what they use that for is they have this lure coming forward, and this is why they're called anglerfish, because they're fishing for their prey. They have a little light on the end of this lure, and that attracts small crustaceans, shrimp, and then they open their mouths and snap them up, and that's their food for the day. And there's lots of different species of anglerfish. Here we have some tiny little animals, tiny little anglerfish. And they do the same thing, so they have the little lure on the front of their heads. And there are strange animals like the spookfish. This is a spookfish, and it has eyes in the top of its head so that it can see directly upwards into the layers of water above, looking for prey. And on its underside, it has this flat surface here. And that flat surface, probably better to see in this one here. You can see this flat surface on the underside. Now that lights up, and that means that the animal is almost invisible to predators who may be looking up into the slightly lit up depths below. So these animals will be looking up and seeing nothing because they've got a little light under here, and this is called countershading. Now the oceans have got a huge number of species that we know about. So all these animals here, we know their scientific names. But in the deep ocean, we don't have the names of all of the animals that live there. In fact, almost 90% of the marine species that we find at depth are new to science. And this is work that we here at the National Oceanography Centre are working to improve. So we're describing new species to science every day.
That's amazing. Life in the ocean is fascinating. I feel sure that with the incredible work that scientists around the world are doing, like those at NOC, we will continue to discover new life in our oceans and protect what's already there. But remember, protecting our planet is not just the responsibility of scientists. It's also down to all of us to do what we can to save our ice and oceans. You can. Think about walking instead of using the car. Many of us drive to school. But could we walk some or all of the way? This will help to reduce our carbon footprint, which means that we are helping to reduce the effects of climate change. We can also be careful with the amount of energy we use at home and in school. Try turning off the lights when you leave a room, or putting on a jumper when you feel cold rather than the heating. Plastic pollution is a big problem in our oceans. Plastics that end up there can contribute to habitat destruction and entangle and kill marine animals. So why not use a reusable water bottle rather than buying a single-use plastic? Encourage people at home to take a reusable cup to get a coffee rather than getting a disposable one. Or take reusable bags when you go shopping, or a bag for life. Remember, Frozen Planet 2 is available to watch on BBC iPlayer. And you can watch the full Frozen Planet 2 Science Live lesson on the BBC Teach website. Visit bbc.co.uk/teach or search for BBC Teach Live Lessons on iPlayer. Many thanks also to the RRS Discovery and RRS James Cook for letting us on board, and to Matt and Tammy from NOC for their insights into the ocean. I hope that you have enjoyed the last hour. We'd love to see you again at 3:30.